I talked recently about our new profession, programming in architecture. And I want to try to explain it even more clearly by introducing a new term into the game, digital formwork. Now, what is a formwork? It's a mold. You have seen it on a construction site before a concrete structure is poured. So what are the characteristics of a formwork? It is made specifically for the building being constructed, and afterwards we just throw it away, or recycle a part of it depending on the complexity of the form and the uniqueness of the formwork. So this is what we are trying to do, only digitally. We create a software for one use. It is a software designed to solve specific problems in a building. Now, talking in abstract terms is opposite of everything that I stand for. So let me give you an example of how it looks, based on a project we finished recently. So we were working on a part of the building that had many unique steel elements, with different purposes. And there were hundreds of conditions and rules that we had to follow. Now be patient with me for a minute. This is how it begins. Start generating steel elements using the existing position of steel beams. Choose the size of the element based on the distance of the straps and the distance of their center to the glass elements. Generate a vertical plate to hold our structure and connect it to the other existing elements. Generate bolts to attach the structure to the other elements 50 to 150 mm from the edge, and then space them out so that the distance is between 200 and 300 mm. Generate long holes to fix our structure to the vertical plate. Generate the main horizontal plate based on the facade curvature. Add stiffenings on the top to fit position of steel girders. Add stiffenings on the bottom between 100 and 300 mm from the upper stiffening so that it doesn't collide with other elements. Generate the holes so that the worker can approach the bolts. The minimum distance from the bolt to the strap can be 55 mm from the upper and 95 mm from the lower stiffening. There are 3 special cases for holes if you cannot position them. Set the horizontal holes for additional facade element fixings. The distance between them should be between 200 and 400 mm, and there should be at least 3 of them, and we need at least 100 mm from the edge. Set the bolts for protection strips. Now set the crane holes 30 mm from the edge and 150 to 200 mm apart. They cannot collide with other elements. Set the rectangle cutouts to fix the facade elements. In order to determine their position, call the function that analyzes the position of facade elements. Trust me, the list goes on and on. This is just a glimpse. There are hundreds of different conditions that I could list that were programmed, and many of them were non-linear, starting with if and being deeply interconnected with every other element. So change one and everything changes in a chain reaction. Now let us sum up what this small real-life example demonstrates. Whatever software you make for general use in architecture, people will want more interesting, more complex, more intelligent, and you will need a one-time use software to answer those desires. Algorithmic architecture is not an extravagant approach to building, it is a necessity. When you have the code, all of the elements are generated automatically, 3D geometry, 2D blueprints and files ready for CNC production, so you have a high degree of control and automation. The development of specific algorithms is not a waste of time. On the contrary, it speeds up our progress immensely. The recyclability is the most important factor, because with every new tool we develop, we write methods and functions that we can later reuse for solving similar problems. And the more experience we have, the more our library grows. And the more we feed on hard problems, the more muscle we gain, and we're able to tackle more challenges. So with a sufficient amount of challenges, the progress is almost exponential. Digital formwork is the future of architecture and structural engineering. With the proper use of prefabrication, 3D printing and robotic assembly on a small or big scale, we can get rid of the old formwork and let the digital one replace it. Or we can at least produce the good old formwork automatically.